Today we will talk about the spinning, which is the basic process in production of textiles. The basic requirement of any fabric is the yarn. Majority of the fabrics available in the market today are either woven or knitted with the yarns, and these are all used for either apparel purpose or home textile purpose. But some of the fabrics for the industrial purpose and also other purposes are made out of non-woven fabrics category. But it is believed that man learned making of the yarns and also weaving of fabrics by observing the nests of the birds. Actually, making of these yarns is something like making wicks for home lighting. So, to define spinning, spinning is a process of drawing and twisting a bunch of fibers into a continuous strand called yarn. The definition holds good only for the staple fibers such as cotton and other natural fibers except silk. But for filament fibers, that is from artificial, that is synthetic and man-made fibers, the spinning also includes the manufacture, because these polymers are not available in fiber form in nature. And so, we require to actually produce the polymer in the form of a filament in case of all artificial fibers. So, based on kind of fiber and also the type of yarn required and the intended end use, the spinning is classified into two major categories. One is mechanical spinning and the other one is chemical spinning. While mechanical spinning is applicable to all staple fibers, when you take examples of cotton and all other natural fibers except silk, and the chemical spinning is applicable to all artificial fibers. Mechanical spinning. There are a number of spinning methods that are in vogue today. The selection of the spinning method depends upon the type and kind of fiber and the type of yarn that is required and its end use. Three major methods. Ring spinning is the oldest and fastest method of producing yarns. Other major methods are open end spinning and then air jet spinning. Maybe some other minor methods are available today, the techniques are available, but still these are the only three major methods which are employed for production of majority of the yarns available in the market today. Ring spinning, it caters to the actually need of the yarn by providing more alignment of the fibers to the yarn axis. Thus, there is possibility of actually making the yarns more stronger. And this ring spinning is applicable to all shorter fibers like we have cotton, flax, and we have wool and all other natural cellulosic fibers, and also the man-made fibers which are cut into staple fibers and then blended with the other fibers. So, for all these things ring spinning is being used, but the ring spinning, again the quality of ring spun yarns depend upon the type of fiber used, fineness of the fiber that is being used and the quality of that, and then the amount of processing that is done while producing these things, and the amount of twist that is being imparted in the yarn. The properties of ring spun yarn, it depends upon the amount of alignment and also the amount of longer fibers that are present in the yarn. So, longer fibers with good alignment will produce stronger yarns than shorter fibers and also poor alignment. And coming to the production of ring spun yarns, there are certain stages in which the mass of fiber changes and then transforms into a long strand of yarn. And so, these stages are, first one is formation of the lap from opening, cleaning and blending operations. Through that we will be able to get lap formation. and then lap to card sliver by carding process, card sliver to comb sliver by combing process, and comb sliver to roving by drawing out process, and then roving to yarn through drawing again and also twisting, and then reeling of the yarn on bobbins or cones or spindles through reeling of the material. While describing the mechanical spinning process, cotton is generally taken as an example as it lends itself to all the operations that are there in the mechanical spinning. The first step in mechanical spinning is opening, cleaning and blending. Opening refers to separation of small lumps of cotton from tangled mass of fibers. And cleaning to remove the trash that is present in the fiber. And also blending is to take up the fiber from different bales and blend them together. So that we will be able to get a uniform starting material for spinning. These are all operations, they are done not one after the other, but these are done simultaneously, and also not only here, they are also the same purpose is being served in the other operations too, that is cleaning and also removal of trash, and also blending is still carried out in other steps also. But here when we take the cotton comes out in the form of bales to the spinning mill, and the bales are opened and cotton is taken over a conveyor belt to the opening machine. In this machine, it goes to a blending feeder. From there, it goes to cylinders with a kind of sharp spikes they have, and these spikes will be able to open up the cotton from the lumpy cotton, where so much tangled that cotton is being opened with these machines. And the cylinders are there which will revolve at a very high speed, and then take this fiber and they make it into small lumps. The number of cylinders required again depends upon the type of fiber and the fineness of the fiber that is used. Generally, cylinders like porcupine machines cylinders are being used for this purpose, and which will remove the lumps and then make it into smaller tufts of fibers. And these revolve usually at a speed of 1000 revolutions per minute. Thus, the fiber comes out in small lumps, and also the trash that is present over there, like maybe some seeds may be present, some burrs may be present, or some dust which is suspended, it may be present. They are all removed, and in this process, I think around 1/3 of the trash is being removed. And then the cotton which is taken out from this is being made in the form of a sheet and called a lap, and this lap is a thin one. It is having a width of around 40 inches and thickness of 1 inch. So, this lap is taken from this machine and then placed over a carding machine. The next step is to align the fibers and bring them little parallel together, so that we will be able to get a strand out of these things. So, this process is called as carding, and the purpose of carding is that to separate again into a smaller lumps, again the lumps into fibers, separating the fibers, so that we can even remove the excess trash that is present in that. And secondly, to make the fibers parallel to each other, so that they will be parallel finally in the to the yarn axis. And so, these are the two purposes of making the carding. Carding consists of a machine, and several machines are there in the mill. Each carding machine has a cylinder and a belt. The cylinder is having very fine hooks or wire brushes, and the same way even the belt contains fine hooks or also wire brushes. These two actually will be over one above the other and will be moving in concentric magnitude. Okay, but when they are moved towards only one side, one direction, but the speed is different. The cylinder moves very fast, whereas the belt revolves at a slower speed. And so, due to the difference between the speed cylinder and the belt, the fiber becomes teased over there and it gets straightened over there, and thus the straightened fiber forms a filmy surface on the cylinder. When it becomes a filmy surface, what happens is whatever dust that is present will fall and then it will be collected by the carding machine. And so, the filmy web, we call it as a web, filmy web now, which is present, it is very difficult to take care of it during the further processing. And so, it is made in the form of a rope by passing the web through a funnel shaped device, so that a sliver, we call it as a card sliver, that rope like mass, we call it as a card sliver, and this sliver is being made and out of each carding machine. And this card sliver is a very loose one and containing fibers which are random, but a little bit of alignment is present in these things, and it has no strength at all, and when you pull it, it will be just pulled away, and so there is no strength in this card sliver. Wherever there are inexpensive fabrics are required, inexpensive yarns are required, and they go for this carded sliver. Carded sliver is directly made into yarn, that is, it is attenuated and given some twist and being made. Something like towels, we can see that there is no strength required there, and we need the fabric to absorb water. So, in such cases these card slivers are being utilized. Then the carded slivers, when we take, they do not contain much fiber inside, they are not compact. So, in order to make them in a compact slivers and also to make them more uniform, doubling is being done. So, it is nothing but bringing a few slivers together and make them into one compact sliver of around half to 3/4 inch wider. That much carded yarn is being taken. The next step of mechanical spinning is combing. Combing is done only to the yarns which require superior quality, and this combing is nothing but it straightens the fibers further and bring out more alignment in the fibers and also remove shorter fibers. And also due to combing, the yarns become more fine, more even, and more stronger also, because only longer fibers are present in this. It will produce very fine, very even, very uniform, and very strong yarns. And this combing machine consists of sets of combs, and each progressive set will be revolving, will be moving at a higher speed. And so, these combs, when the card sliver goes through that, it is made again in the form of a lap and then made to pass through the combing machine, and each set of comb will straighten and then remove shorter fibers which are below ½ inch, and they are called as noils. And these are removed, and finally, when the comb sliver comes out, it will be having only longer fibers and very high degree of parallelism, so that the final yarn is going to be more even and more stronger. And the noils which are removed here, around 25% of that will be wasted like this, and but that byproduct will be a valuable one, because it will have a purpose of using it in non-woven industry. When combing is done, usually it is given on the label of the fabric as combed yarn. So, combed yarn always refers to superior quality in the yarn. Then the next step is the combed slivers are put through a drafting or a drawing step, in which the carded slivers are taken together and they are made in the form of one sliver, because the final yarn, the final sliver that comes out of all these things should be uniform and also should be compact. And so, the drawing in this particular step, several card slivers or comb slivers depending upon the type of yarn required, these are brought together and then they are attenuated to take up the shape and size of one sliver. That means that here they are all combined, but at the same time drawing takes place, as well as the alignment takes place, because they are pulled like this, and then it facilitates more alignment, more parallelism over here. And this drawing frame contains again sets of rollers, and each set has a progressively more speed. And so, when it enters one roller and it takes up this particular sliver, when the second roller is there, it has a more speed. So, due to this, the speed difference between the rollers, they pull the fiber, that means they attenuate the fiber again and then make it into a smaller diameters. So, like this it will be drawn and drawn, and again this will be drawn in the other operations that to come. But here one more thing to be told here is that around 6 to 8 slivers are usually combined, and but when blending has to take place, they will do the blending over here. For example, in case of cotton and polyester blends of 50:50, then 4 slivers of cotton and 4 slivers of polyester are combined together to form a single sliver. So, the single sliver will contain 50% of cotton and 50% of polyester. By pulling action of these rollers, the sliver gets attenuated and becomes longer, and then these slivers, the drawn slivers, are passed through the slubber, and then the similar rollers there also attenuate the fiber into thinner diameters again, and then finally it passes to the spindles, where the first twist is given in order to withstand the strain of the roving frame, and then they are wound on bobbins. The next step in roving operation, further drawing takes place, because the roving frames facilitate drawing and attenuation of these yarns, and finally to get a sliver which has the size of a pencil lead. 2 stages of roving is apparent here, one is intermediate and the final, and both the process are same, but only thing is that the size of the sliver which it receives in the beginning and also when it comes out will be different. That means it is attenuated still, and then a thinner yarn is being produced by these 2 processes. And roving is the final stage before insertion of this twist, and so most of the drawing is completed over here, but even though little more drawing and attenuation continues in the spinning process. And roving here has no strength at all. When you pull it, it comes apart, and so it contains only the enough twist that is required to take up the strain during the spinning process. Spinning is the final operation in the manufacture of these yarns, and spinning completes the yarn formation by taking the roving and drawing it, and then inserting the twist, all in one single operation. Then the twisted yarn is wound on spools or bobbins and all this happens in one operation, that is drawing, twisting and then winding, it takes place in one operation. The spinning frame consists of sets of rollers, and each roller again, in case of roving and other drawing operations, here also there is a speed difference between the first roller and the second roller. And the difference between these 2 rollers, the speed, that will facilitate attenuation of the slivers further, and the slivers become very uniform in size, and also the proper alignment is present. And so, these are fed again to the spinning frames, and there are two kinds of spinning frames that are in vogue today commercially, and one is the ring frame and the other one is the mule frame. Ring frame is employed when the process has to be done at a faster speed and also to produce some coarser yarns. But when fine yarns are produced, they have to definitely take the mule frame. Mule frame is a slow process, but it produces high quality, very fine yarns. So, the ring frame, when you take it, because it is a commercially viable one, that ring frame contains one U-shaped traveler, and it will be winding round one spindle, that is take up package. So, it will be going around that, and there is a difference between the speed of this U-shaped traveler and also the take up package. The traveler moves at a slower rate when compared to the take up package, and so the roving is fed through this U-shaped traveler onto the bobbin which is placed in the spindle. The spindle rotates at a very high speed of 13,000 revolutions per minute, and whereas this U-shaped traveler will not be moving so fast. And so, the difference between these two will produce the twist in the material. It also attenuates again and also impart the twist in the yarn, and then the yarn, after giving the twist, the final yarn will be taken in the form of skeins or wound on bobbins for further processing. So far we learned how the shorter staple fibers are made into long yarns by mechanical spinning. But if the fibrous material is not available in fiber form, then we need to spin it by manufacturing the fiber and then giving the twist. And so, this part of chemical spinning we will be dealing in the next episode.